We're going to do a couple of gas pressure calculations just to get us used to using the gas formulas that we learned in the last two lessons. So in this problem we're told that when the volume of air in the syringe is 200 millilitres, its pressure is 175 kilopascals, and then what is the pressure if the volume is reduced to 120 millilitres? So this is a situation where you're finding the pressure with a changing volume at a constant temperature. So we're going to use this gas law where we have pressure multiplied by the volume is equal to a constant. Now what that means is that wherever I position this piston, the value of the pressure multiplied by the volume is always the same. So we can write this as P1 V1, so that's the pressure and volume at some position 1, is equal to the pressure in the container and the volume at some other position 2, P2 V2. So this is the starting pressure and volume, and this is the final pressure and volume. So all we need to do is substitute our values in. So we have 175 kilopascals multiplied by 200 millilitres is equal to the pressure that we want to find, that's P2, that's the unknown in the expression, multiplied by the final volume, which is 120 millilitres. So all we need to do is get P2 on its own, and to do that we divide both sides by 120 millilitres. Alright, so that gives us P2, that's the final pressure, is equal to 175 kilopascals multiplied by, divided by 120 millilitres, which gives us 291.7 kilopascals. So that's one type of calculation that you may encounter. The other type of calculation that you might encounter is one where you have a constant volume and you have to calculate the pressure due to a change in temperature. So in this problem we have a container where the initial temperature of the air is 300 Kelvin at a pressure of 100 kilopascals, and we need to find the pressure when the temperature is increased to 400 Kelvin. So this time we're using the other gas law, which is written as this. We say P, that's the pressure divided by the temperature, is equal to a constant. And as before, we can say that as we increase the temperature in this container, the value of P divided by the T is always the same. It never changes, providing the volume remains constant. So we can say that the initial pressure, P1, divided by the initial temperature, T1, will be equal to the final pressure, P2, divided by the final temperature, T2. So all we need to do next is just plug in the values as we did before. The initial pressure is 100 kilopascals divided by the initial temperature, which is 300 Kelvin, is equal to final pressure, P2, which is what we've got to find, divided by the final temperature, which is 400 Kelvin. So we want to get P2 on its own, and to do that we're going to multiply both sides of the equation by 400 K. Right, so the final temperature, P2, will be equal to 100 kilopascals divided by 300 Kelvin multiplied by 400 Kelvin, which equals 133 kilopascals. Now, the one thing that I should point out for you here is that it's quite possible that in an exam question, the examiner may try to trick you. For example, in a problem like this, where you're given the temperatures in degrees Celsius. So, for example, if they say that the starting temperature is 20 degrees Celsius, then you must convert that into Kelvin before you plug it into this equation. So to do that, we have to add 273 to the temperature in Celsius, which will give us 293 Kelvin. Okay, and then we plug those values into our equation, and we can then calculate the pressure correctly. So watch out for that. Always degrees Celsius into Kelvin.